Okay, so this is going to be for my engineering design class. We're going to go through the Solidworks CSWP Sample Exam 2 for the segment 3 of the CSWP core exam. Basically, it's going to be the second file here, which is the Solidworks CSWP. We'll need to download and unzip our files here. This is for the Part 3 Example 2. So I'm going to first open this up and get my PDF file open. So I'm going to go ahead and open a PDF file here. Get this up and running. So this is what we're looking at. I printed a copy for my benefit so I can kind of go through this. It's not easy to always read through here, but I will reference this as we go along and go through all these little different parts here. In addition to that, I want to go ahead and download this right here. I'm going to go ahead and save the file. I'm actually going to save it to my desktop. So I'm actually going to put this on the desktop, say save. And then I'm actually going to have to go to my desktop here. And now you're going to see is right here, CSWP Part 3 Exam 2 zip file. So what I'm going to do in this case is right click, and I'm going to do an extract all or extract files. Okay. It's going to ask where, desktop. I'm just going to go ahead and say OK. And it should end up creating a folder right below. Okay. And inside that folder, you will see all the parts we need for this part of the assembly. Okay, so with that done and taken care of, I am now going to come back into SolidWorks. We're going to go ahead and get this thing started. So let's look again really quick at the PDF file. So the first thing I'm going to do is we're basically going to create a large, and I'm actually going to shrink this down just a little bit. It's a little too big. Okay, what we're going to do is basically create, and I'm just going to kind of thumb through, we're going to create a large assembly. Okay, and this is really what the segment 3 is about. There is a couple of, I think, problems on there, but the real big emphasis is on assemblies. Being able to get the parts in there, being able to do advanced mates, some of the ones we've never done before, understanding interference detection and collision detection and things of that nature. Okay, and so we're going to go through that whole process here in order to find some key information about our assemblies. Okay, and this is really what they've changed the test to. So this is a really good one. There's going to be a couple parts that we have to create, some sub-assemblies we have to create, and of course a lot of it is about finding your X, Y, and Z's. Okay, your center of masses. So with that done, let's go through here. I'm going to go to the first part. It tells me we're going to do it metric, which is pretty common. It's a universal test across the world, so it's going to mostly be metric. We're going to create this part right here, a base. It's going to be made of brass. Okay, we're going to use this information here, and then we're going to find the mass, and we're going to put that into the assessment that has been attached to our Schoology lesson. Okay, so let's go ahead and pull this up. In this case, I'm going to go ahead and get my SolidWorks up and running. I'm going to start this from a top view, so I'm going to make this pretty straightforward. I'm going to go, actually, excuse me, I'm going to do it from a, in this case, a right side view. I'm just going to kind of look at this, or a front view. I'm going to go ahead and do a front view on this, and then go ahead and kind of get this laid out. And honestly, looking at this, kind of the way they orient this, especially a little bit later, I'm going to jump ahead. I'm actually going to go to question 2. I want to show you something. This is what threw me off the other day because I had to kind of keep orienting it every day to figure out where things were at. Because this is going to be a critical part right here, I'm actually going to start this on the front, but I'm going to reverse my sketch. Instead of having the slope on this side, I'm going to reverse it to this side so that this corner will always show up in this isometric view. Okay, the first time I designed this, I had flipped it, and then I kept having to reorient it to get the orientation correct, and it was really kind of a pain. It took a lot of extra time. So I'm going to flip this. So instead of this way, like you see here, I'm going to flip this over to this way. Hopefully that makes sense of why I'm doing it. Okay, that's why it's important on those exams. Look ahead to see what they want you to do, see if there's any pitfalls, okay, and then make your plan. So that is going to be my plan right there. So going back into my SolidWorks, popping this back up, I'll start with the metric part and say okay. So I'm going to go ahead and start on the front plane, like I said, with a new sketch. I'm going to do the line tool. Now in this case, I don't care where I start because I'm going to actually add the coordinate system on, so it doesn't matter where I start. So I'm going to go ahead and start this by going over to my left, going up a little bit, back at a slope, and then straight back, and then down. I'm going to hit escape here. Okay, I'm going to go ahead and throw some dimensions on from here to here. It's going to be 25 millimeters tall. The front here will be 12.5 millimeters. Let me see, the overall length of this on the bottom will be 200 millimeters. And then I'm just trying to see what we got here. The distance from this point here, this comes from the, basically looking at the top cut where that line is, it's going to be 60 millimeters. Okay, 60. All right, now I'm going to do a mid-plane extrusion. I would always try to do everything with mid-plane extrusions and mid-plane cuts. Again, I want to try to focus on keeping planes in the middle of my part. It makes it a lot easier for assemblies. So in this case, I'm going to go to my features. I'm going to go ahead and do a extruded boss base. It flips to the orientation of isometric. I am then going to go from blind to mid-plane. I'm going to extrude this a complete distance of 120 millimeters. And hit my check mark. Now I'm going to go ahead and add that brass on here right now. Okay, so I'm going to go ahead and right click. I'm going to use the hotkey right here where it says brass, make it much faster than having to go search for it. Okay, in this case, I'm going to go back to my front plane again and start another sketch. I'm going to do a spacebar and a normal 2. I'm going to start by drawing basically, I'm going to use a center line here real quick. The center of this is going to be right in the middle. It's going to actually be in the middle down here. It's 100 millimeters in, so this is going to be dead center of the part. So I'm going to go up here and pull it straight up. Now this does not necessarily show in there, and this is kind of where sometimes these files I purchase, which is what I did, I bought this file, they don't always have all the dimensions. I'm just going to tell you from looking at it, it's dead center of the part, and it's dead center at 100 millimeters. So from here, I'm going to go ahead and turn on my line tool. I'm going to draw from this line here. On top of this line, I'm going to come over. I'll go this direction and then angle down and then finish with a close. Okay. Now, a couple things. I'm going to go ahead and turn on my smart dimension. Go from this angled line to this flat surface and make that angle 105 degrees. I'm going to go from the very top line here to the bottom, pull that out this way, should be 40 millimeters. And then the diameter of this outside circle, actually on this case, this bottom, it's going to be from here to this line. Now remember, to do a diameter, you pull to the right of the center line. This will only work if you do a center line. If you don't, it's going to be half of 45. In this case, I've got a diameter there, so I'm going to go 45 millimeters. And now it's fully defined. I'm going to do a space bar here and go to my isometric. And I'm going to go to features and do a revolve boss base. Okay, and hit my check mark. Now I'm going to go ahead on this top surface here. I'm going to go ahead and start a new sketch. Do a space bar and a normal 2. Draw a small circle. And head to here. Create a diameter of 20 millimeters. Okay, I'm going to go ahead at this point. I'll come back and do my space bar and do this. And features, extruded cut. And I'm going to do a through all. Now I know I'm going through this fast. You can pause the video at any time you need to as necessary. Okay, now I'm going to go ahead and highlight this top surface. Start a new sketch, space bar, and a normal 2. I'm going to start with 2 rectangles, one coming this side and one on this side, but this one will actually end right here on this line. That is that 60 millimeter measurement I made. I'm going to hit escape, turn on my smart dimension and dimension from this edge to this edge at 30 millimeters. This distance across will be at 60 millimeters. Now you could do the same dimensioning over here, or if you wanted to, you could actually go ahead and use some relationships like control and taking these 2 lines and make them collinear so they're on the same line. Do the same thing down here, collinear. You could also make this line here equal to this line so they're both at 60 millimeters. Okay, that way if you change anything, it will change both, which is an important feature. Okay, spacebar isometric. Features, extruded cut, and through all. Turn on my features toolbar and turn on my fillet. My fillet tool says it's going to be a radius of 10 8 times. So I'm going to go ahead, the 10 is default, and I'm going to hit each of these corners on the outside. And then each of these corners on the inside. So there's 6, and then here's 7, and number 8. There's my check mark. All right, that is done. Okay, now it wants you to go through here, and it wants to know the mass. I'm not going to tell you the mass. You need to do your mass properties. If you do it right, if you've done what I've done, you should get it right on the money. At that point, I want to do a file save as. I'm going to save these to my desktop right now. It would be good to set up a folder for this part, but I'm going to go ahead and do it on my desktop because I already got multiple folders. I'm going to go ahead and put this to desktop, and I'm just going to call this the base. Okay, I'm going to call this base, whatever, base part. You can give it whatever name you want. Just make sure you know it's a base. All right, so that takes care of number 1. Now what it says in number 2, so if I go to here, I would now know my mass, because I just did the mass properties. Okay, you're going to fill that in. Now it says number 2, what is the center of mass based upon this new coordinate system? Okay, so this new coordinate system right here. So now what I'm going to do is go to SolidWorks. Under my features, go to Reference Geometry, Coordinate System. I'm going to go to this corner and left click on it. Now you got to be really, really careful when you're looking at this, okay? It's telling you the Z is going in this direction, X is going in. So we need to make sure we have that exact same setup. Okay, they know people mess this up. So Z right now is in the wrong direction. So I need to go to where it says Z right here, and I need to flip it. Okay, so Z is going that way. And actually, you know what I'm going to do? I'll take that back. I'm not going to do it that way. I'm going to take and deal with the X direction. I'm going to put X right here. Y. Wait a minute here. X. Revert. Wait. Oops, sorry. I had it right. There we go. Sometimes you just have to kind of play with it and click with it until you get the setup the way you want to. Okay. In this case, I got the Z going into the right. X is going into the part to the left. And then Y is going up. Okay, hit my check mark, and now here is my XYZ coordinate system 1. Now, if you want to maintain that so you can see it all the time, come up here to the all wandering eye right here, drop that arrow, and turn on your coordinate systems. Okay, that way this stays on the entire time. You know it's there, and I like to keep it on so I know it's still there. Now, what it's asking you to do is then go up here. You need to go to your evaluate and your mass properties, and you need to get your X, Y, and Z. Now be really, really careful here. This is not the correct center of mass, and the reason being is because I am at the default coordinate system, which is the one that's over here somewhere in the corner, or over in this corner. I forget where we started. I want it for coordinate system 1, and this is really important to remember, and this is where they try to get you. I guarantee this is one of the answers that are in the choices because they know you're going to forget to change the coordinate system. I've had students go through and do this test thinking they got everything right and missed every single one because this answer was there, thinking they got exactly what they wanted, but they didn't have the correct coordinate system. Okay, so make sure you pick coordinate system 1, and then from there, make the proper choice in the assessment. Okay, so I'm going to do a quick save right here and go on to problem number 3. Okay, so if you're looking at this, problem number 3 now is telling you to add this part in. So this is from that folder that we downloaded. So I'm going to go from here, and I'm going to go ahead and get my SolidWorks up. I'm going to start with a file new. I'm going to go ahead and start with a tutorial and assembly. All right, and the first thing I want to bring into this assembly is my base part. I'm going to bring it outside here and left click. Now from here I'm going to bring in my other component. So now I'm going to go browse for it. This is the one that's on my desktop, so I have my folder again, which is sitting right here, example 2. Okay, and in here, I like to make mine for bigger pictures so I can see everything nice and clean. And then I'm going to go ahead at this point and grab the arm mount and say open. I'm going to bring this above. Now you got to be careful because it does in these things, and it will show you in the test too, it makes very explicit this must be parallel to this side, this is concentric, and then this is going to be coincident at that base. That's what all these symbols are. So you need to know your symbols. Okay, so I'm going to go here. I'm going to add my concentric mate first. Okay, check mark. Add this mate right here. So I have my coincident, so there's two of them. And then I'm going to make this face here parallel. And I'm going to flip that parallel, flip it the other way. So I just did an anti-alignment. Alignment's right here, aligned, anti-aligned. Okay, and hit my check mark. And go back to my isometric view so I know that I'm in the right spot. Okay, now let's see what it's asking for in our file here. It wants the center of mass based upon this XYZ coordinate system. Here is the problem. All right, if I go into this assembly right now and try to do an evaluate and a mass properties, it will not have a coordinate system 1. You have to add it into now also this assembly itself. So you have to add a coordinate system in again. So there's a coordinate system on the part, but that does not register in the assembly. So now I have to go into here under assembly, okay, and I can go to reference geometry, coordinate system, and again I'm going to attach it right there. I'm going to make sure my X is in the direction going to the left, Z to the right, Y going up. I'm going to hit my check mark, and now that is my coordinate system. Now again, I'm going to turn it on by going to the all-seeing eye. I'm going to click on this right here, so there is my coordinate system. So now when I do my mass properties, evaluate, I now pick this coordinate system 1 to get the correct answer. I'm not going to show you that. You need to find it and pick the correct answer in the assessment provided in Schoology. Okay, so that takes care of question number 3. So you can see we're kind of moving at a pretty good clip here. Remember, it said you should be able to do all these problems in under 80 minutes. We're going to try to shoot for under 45. Okay, going to problem number 4. Next. Okay, so there's 3. 4. It says now we're going to add in the lower arm. Okay, so we're going to bring in this lower arm. One of the things we have to do is we have to add a concentric mate for these holes, but we're also going to have to add in a width mate. Okay, this is going to be new. I'm going to add in a width mate here. All right, so we can center this up, and then we're going to add a parallel here. All right, then again, it's going to ask for the new center of mass based upon X, Y, and Z. So this is kind of how the whole process goes. So, going back into my Solidworks, I'm going to go ahead and go back to my Assembly tab and insert another component. Browse, and I'm browsing for the lower arm right here. I'm going to open that and bring it in. Now, turning on my mate tool, the first thing I'm going to do is add in concentric mate to that hole there. I'm going to do the same thing on this side also, just to make sure everything's lined up. Now, the problem is, yes, it's lined up to the holes, but we have to get these things here centered inside this gap. So what you're going to do is go to your advanced mates right here and expand out the advanced mates. And what you're going to look for is width. That is the symbol you see in the PDF file. So I'm going to go to width. All right, so it wants the width selection. So what I'm going to do is go here and click on the outside of that and the outside over here. Then it wants the tab selection. So I want it to be centered inside this tab and inside that tab. And then your choice is center. Now you can change it, but the constraint's pretty much always centered. Okay, so now if you look at this carefully, this is perfectly centered inside that tab on both sides. Okay, hit my check mark. And then go back into my standard mates here, because I have to add one more critical mate, which is this top surface here must be parallel to that surface there. Hit my check mark, spacebar, isometric, close out my mate tools, and now at this point I'm going to go ahead and do another evaluate. So you do evaluate, and again, when you do your mass properties now, do not forget to make sure you're under coordinate system 1. Once you've done it one time, it should automatically come up every single time. Okay, so now you're going to enter in your coordinate system in this case, into question number 4 right here on the assessment. Okay? Now, from there, we're going to come down to question number 5, collision detection. So what it's going to say is delete the parallel relationship from question number 4. So I'm going to get rid of that parallel relationship, or the parallel mate. And we're going to rotate the assembly as shown to where it touches. Okay, use the collision detection. So this is new. We've never done this before, but this is something we got to get used to because this is great for design. It's important to know if I'm going to build this, is something going to collide with something else so I don't waste a lot of money. So going back into SolidWorks, I am going to go over here to the mate. I'm going to right-click on this, okay, and hit delete. So now this can move freely, okay? Now, under Assembly, you're going to go to Move Component, or click on the Move Component. Okay, just click on Move. One of your selections over here is Collision Detection. If you turn that on, basically all they ask you to do is make sure it says Stop at Collision is on there. And this is all it is. It's that simple. I'm going to take this right here and drag it down, and it will stop. Boom. As soon as it goes there, you can see it's collided by this turning blue. It will stop there. Okay? So this is what we want to do. We want to drag it till it stops. Close this off. Okay, now I'm going to go ahead and I'm going to do a quick front view because what I want to do is go to my Evaluate in my measuring tool. So here we go. We got another one to use here. So here's my measuring tool. It is on. I'm going to click on this line right here and this line right here. Okay, you want to make sure this is expanded below. Because what we got here is this is the angle between that line and this line. This is the angle they're asking for when it says, what is the angle of X? You're welcome. You got a free answer. Okay? That is how you go through this. So they're going to ask this a couple times. You're going to see this throughout this. What is, make this move here. Now measure the distance or this angle between here and here. And you're going to have to use your measuring tool. Okay? I'm going to close that out because now that is done. That takes care of question number 5. Okay, we're 22 minutes in. Halfway where I want to be through 11 questions. So we're perfect. Now we go to question number 6. Okay, question number 6. All right, create a new assembly. So we're going to start a new assembly, and we're going to bring in our shock housing. Okay, this is going to become a sub-assembly, so we're going to call it a shock assembly. But what we're going to do is by first going in, we are going to go to SolidWorks. Let's come into this part. Doesn't matter. I'm going to do a File New. We are going to start with a new assembly and say OK. And we are going to start by bringing in the shock housing. Now, honestly, all they're asking is, what is the mass of this? This is how simple this is. All it is, and in this case, if you want to make sure, it should have a 6061, whatever it is. It comes in with the material. So all you have to do on this one, literally, is click your mass properties and type in your mass properties right there. That's how simple. And some of the questions are super, super easy. Like this would be a 5-pointer on the CSWP Part 3. Okay, so that takes care of question number 6. So 23 minutes in, we're over halfway done. Okay, now we go on to question number 7. And if I look at question number 7 here, it says in here in question number 7 to add the piston. Okay, so we're going to add this piston and we're going to add a distance mate here. All right, we're going to make it concentric. We're going to make this face parallel to that face, and then we're going to add a distance mate in here. All right, so going back into SolidWorks, I am going to go ahead and add in assembly, insert, and we are going to bring in the piston. Okay, here is the piston. All right, there's my piston. I am now going to go ahead and mate the piston, this outside edge of the piston, rotate to the inside here, concentric. I'm going to make this face here and this face here parallel. Check. And now what I'm going to do is I'm actually going to use, I got to get out of this tool for a second. I'm going to use this sectioning tool to open this up. Okay, so I can actually use the section tool. I'm going to open it up like so and hit my check mark so that I can see the inside. And that's this tool right here. I know we've never really played with this, but here we go. Okay, now turn on your mate tool, click on that bottom face there, and this face here. And instead of concentric, or coincident, excuse me, we are going to click the distance mate of 40 millimeters. So there we go. There's our 40 millimeter distance. I'm going to hit my check mark, close this. I'm going to go ahead and turn off my sectioning tool because otherwise your math is going to be wrong. Okay, I'm also going to do a quick save. So I'm going to do Control S. We're going to save this. I'm going to call this shock. I'm going to call it Subassembly. I know it's already in the folder, but I do expect you guys to go ahead and do this correctly. Okay, because you're not going to have this option. Subassembly. Okay, so there's a subassembly. And now what I want you to do is, what is the mass? So again, you go into your evaluate, and you should have the mass. And that's based upon the chrome stainless steel of the piston, and this 6061T for stainless steel tubing here. Okay, now you should be able to have that mass. You are then going to go ahead and circle that answer, okay, or choose that correct answer on that. I'm not going to give that to you. That is in the assessment. Okay, so that takes care of question 7. Moving on to question number 8. Okay, now adding in the subassembly. So what we're going to do is we are going to go ahead, add in the shock subassembly. We're going to add in the upper arm up here, okay, this knuckle here, and we're going to create this assembly as seen. So now what I'm going to do is go ahead and get back into SolidWorks, bring this back open. Okay, now this is basically free to move. Okay, I'm going to get back to my isometric. We're going to continue adding on stuff here. So I'm going to go ahead now to Assembly, Insert Components. I'm going to bring in my shock subassembly. I'm going to insert another component and bring in the upper arm. I'm going to go ahead and get all this stuff in here. So there's my upper, okay, open. And then I'm also going to go ahead and insert what's called the knuckle. Browse, and here's the knuckle. All right. Big thing here, same thing we did before for the lower arm. We're going to start with our mate tool. We're going to make the inside of this hole here. We are going to make it so that it is concentric to that hole there. I'm going to do it for both sides just to make sure this is straight. Okay, so we made that not coincident. Nope, nope, nope. Concentric. Okay, and then again, to get in the correct spot so it's centered, I am going to go to my advanced mates. Width selection, I will pick this side of that knuckle, or the upper arm, and the outside here. Then with the tab selection, I'll pick the inside of these two tabs. Okay, and now your upper arm should be centered within that space there. Okay, I'm going to go back to my isometric. So now you can see this is free to move, this is free to move. Okay, so we're doing okay. Now, from here, I'm going to go ahead and bring in the knuckle. So what I'm going to do at this point is I'm going to actually get out of this for a second, go into Move and Rotate component. Okay, so here's my Rotate. I'm now going to come back into my mate. Same thing we got to do here. I'm going to go in and make this concentric to that hole. I'm going to make this down here concentric to this hole. All right, and then the same thing we've done before, we are now going to go ahead to our advanced mates. So you're going to get used to this. Width, I'm going to take the outside of this face here, outside that face there. Oh, hold on, take that back. Clear, sorry, clear that. Clear selections. I'm actually going to do it the other way. I'm going to go this face here, sorry, this face here, and I want it to go with the tab here, and, oops, sorry about the rotation here. Let me blow up on this, and that one there. Okay, so that should center this so that both of these are sitting right where they're supposed to be. All right, so now if you're looking at this, this here is all moving together. Okay, that's perfect. Now, it comes down to this. Turn on my mate tool. I'm going to go in here, put this into this hole right here with a concentric mate. And then again, I'm going to go to my advanced mates. Same thing. You're going to see this over and over and over. Width mate, I'm going to take that face of this piston, this face here, and then hit it to center inside these two tabs. All right, and I'm going to close this out for a second, okay, because here's the problem. Right now, if I try to go in to make this hole right here 30 fit or be concentric to this hole, it will not work. Okay, this whole assembly here is completely frozen. It comes in as a basically fixed. Okay, what I mean is it won't move. So when you bring a subassembly in that you would like to use, you have to make it flexible. To do that, I'm going to go to my shock subassembly over here to my left on my design tree. And if you left click on it, right here is a little box that says make subassembly flexible. If you left click on that, now you can basically, oh, maybe not. Did I make it flexible? Let me make sure I did that. Is it flexible? Okay, it should now work. So if I add in my mate, I don't know why it didn't move there, but if I add in a mate between here and here, that should end up working. Okay, so in this case, I may have lost, maybe I didn't get this. I need that to be concentric. There we go. Okay, I may have lost that one. So now this should all be able to supposed to be able to move, but it doesn't seem to be actually in this case. Flexible. Okay, so let me look at real quickly here what the next question was. Sorry, I got to go through this. So looking at this, we got that all done. Those are centered up. Okay, we did this, we did that. Okay, and then it says it wants to know the center of mass. So let me just look this from the front view to make sure we're looking at the right direction here. Come back to this, front view. Yep, that looks like the same thing. That's exactly what they're asking us to do. So now, again, same thing. You're going to find the center of mass of this by going into your evaluate mass properties. But again, do a rebuild here. Okay, don't forget to change your coordinate system if it's not there. Okay, that's really important. Every time we do this, it's through the coordinate system. Okay, now I believe, I don't know if this is going to be flexible enough. Maybe it's not. I'm going to have to do something with it, but that takes care of, in this case, question number, what was that, 8. Okay, so now you make sure you pick your correct answer from here in the provided assessment in Schoology. All right, we're on question number 9, 9 of 11. So we got 3 more to go, and we're only at 33 minutes. All right, so now it says change the distance between the piston. Oh, that's why it's not moving. There is a distance mate on that piston. Okay, so we need to change the distance between the piston and the shock housing. So instead of the 40 millimeters, we're actually going to make it 10 millimeters sticking outside the piston. All right, this is going to be really, really important. So when I go to here, to do this, I need to come back to actually the subassembly itself. And I need to come down to the mates in my design tree and edit this distance mate and make it, instead of 40, we're going to make it 10. But here's the key. Oops, no, not add it. 10 millimeters. But we're going to flip the dimension. That will help the piston pop out by 10. Now I hit my check mark and close my mate, but the only way to make this work in the full assembly is to rebuild and save. Okay, so now if I control tab and go back into my assembly, it's going to say some assembly's been changed. Do you want to update it right now? Yes. And there you go. There is the change with the piston popping out the back end of the housing. Okay, so going back into that question, back over here, it says, okay, use interference detection to determine collision between parts. Now this is new. So what it's going to do is we're going to use a tool within our assembly that allows us to determine what is going to hit what. All right, so if I go in here, back to Solidworks here, okay, and I go under, in this case, assembly. No, it's not here. Hold on here. Okay, so I found the interference detection. I apologize there for that pause. The interference detection is under your Evaluate tab. And it's right here. It's right next to the Design Study. And when you left-click on it, it's going to start with your assembly, whatever the name of it is. We'll give it a name here in a little bit. Okay, and what we're going to do is simply, the only thing we want to do is make interfering parts transparent. And I think that's it. That's all we want. Create fastest folder, nothing else there. And that even is explained right here where it says, okay, the only box that should be checked is the interference detection option is making interfering parts transparent. So that tells you everything you need to know. And then it says, okay, which parts have interferences? Well, all you have to do once you have this up and running is hit calculate. Now, here's what it's going to show you. Okay, if you open each of these up, it shows you have an interference between your shock housing and your piston. Okay, you have an interference between the arm, lower arm, and the shock housing. Okay, continue on down. You have an interference between the arm upper and the knuckle. You have an interference between the arm lower and the knuckle. Okay, you have an interference between the arm lower and the knuckle. Okay, again, there's another one. And then last but not least, you have another one between the arm upper and the knuckle. All right, so what does that all mean? Basically, in a nutshell, if you go back to here, you check everything you just saw on there, okay, and you do that in that assessment. You pick the boxes of the pieces that you saw with interferences. Okay, that's all there is to it. It just shows you where it runs into each other. Okay, that's what the question's asking. So get that filled in, and let's work on to number 10. 10 of 11 will be done here real shortly. Now, in this case right here, it tells you they want you to create a new part. So again, this is kind of the way the actual test goes. They'll have you start creating new parts halfway through, add them into your assembly, do some other modifications. So we're going to go ahead and go into SolidWorks here. We are going to create a new part in metric that will be plain carbon steel. Okay. In this case, I'm just going to start this from a front view, create this profile you see here in this view, and I'm just going to do a simple revolve. And I'm actually going to go ahead and start by going from the origin with a center line, create this upper part right here, and revolve it around. I'm going to try to do this in one step. So I'm going into SolidWorks here. Doesn't matter where, oops, going here, sorry, go to here. That's all good. I'm done with the interference detection. I'm going to do a file new. We're going to go back to SolidWorks templates and open up a metric part and say OK. Now from here, I'm going to start, like I said, on the front view, from plane, with a new sketch. I'm going to do a center line tool, pull this across like so, doesn't matter which way. I am going to use this line to basically create the following silhouette. I'm going to kind of come up, over, down, over, kind of at an angle, down, and back. And I'm actually got to make a little correction there. I'm going to take that line right there and make it horizontal. Turning on my Smart Dimension tool. And actually what would probably be better than doing this is probably silly to do it this way. Delete. It would have been better off making this a straight line and using my chamfer tool. Okay, so from here, I'm going to make this height from here to this line. Now again, using your center line, you could go either radius or pull below and do diameter. All right, this will be 22. This dimension right here will be 3. Oh, cancel. This dimension here will be 3 millimeters. The overall length of this will be 50 millimeters. 50, and this from the outside edge here to here will be 15 millimeters. And the inside hole from here to here will be 8 millimeters. Okay, and if you want to, you can actually do your actual, instead of fillet, sketch fillet, you can do a sketch chamfer, which is going to be a 2 by 45. So I'm going to do 2 millimeters. I'm going to do an angle distance, excuse me. We're going to do a 2 by 45. $2 by 45, and click on this corner. Okay, so that's done. Go to my Features tool. I'm going to do, oops, get out of this, Sketch Fillet. We're going to go to Revolve Base. Let it revolve around that center line and check. Okay, so that's all there was to this. Okay, we're going to add our plain carbon steel. So I'm going to right click and go to my Edit Materials. And then under my steels, I'm going to go to plain carbon steel. Apply and close. Okay, I'm going to file save this, save as. They want us to call this, in this case, call it the spindle. Okay, and I already have a spindle in there. I see it already in there, and you can use it if you wanted to. But I do want you to start learning how to use your own or making your own, because it's part of the 80 minutes, is can you build this in that 80-minute time frame. All right, so there's my spindle. All right, from here, what it wants us to do is it wants us to go in here and suppress the distance mate of the shock and shock assembly. So what I'm going to have to do here is go into Control Tab. I'm going to go to my subassembly. I'm going to right-click and suppress this. I'm going to do a rebuild and a save. Okay, so now this is free to move. There's nothing holding it in there. Okay, do a quick save here. Rebuild, Control Tab, go back into my assembly and say yes. So now this is free to move around. Okay, by taking that distance mate off, I can make this move. All right, now what it wants us to do is it wants us to suppress that distance mate. Flexible and top level assembly, we've done that, create the part shown below, and then we're going to add in this part. We're actually going to add in a couple things. We're going to add in an angle mate. So it wants us to do a 10-degree angle mate between assembly, mate, between that bottom face there and this face here. We are going to do an angle mate of 10 degrees. Okay, check. Then we are going to close out that mate, bring in our spindle. We are going to add in a concentric mate here. And we're going to make this face right here coincident with that face right there. So there is my spindle as seen. Okay, close out my mate tool. Now what it's asking for is with that angle in there and the spindle, they want to know specifically what is the center of mass of this assembly. So again, you go to your evaluate tool, mass properties, go ahead and rebuild everything, and then make sure you choose your coordinate system 1 and write in or put in the assessment the X, Y, Z that you find in your center of mass. I will not show you that here. I'm waiting for you to put that in for the evaluation. Okay, so that takes care of question number 10. So at that point, we're at 42 minutes. I bet we can get the next one done in 3. Like I said, I was shooting for 45 minutes, and we are pretty much right there right now. So let's look at the last question. Okay, so question number, we get our XYZ right there. Question number 11, replace components. Now this is a unique one because we've never done this before. Okay, in your folder there is another base. So it says replace the part with base B, make the necessary changes on the images below. Angle mate from Q10 is eliminated. So question 10. So what we're going to do first is I'm going to go over here and I'm going to eliminate this angle mate that we just put on there. So I'm going to get rid of this angle mate. I'm going to actually suppress it. Okay, so that angle mate is no longer there. That's done. Okay, it looks like it also wants us to go in here and add a mate of 80 millimeters in our subassembly. So I'm going to go back right away to the subassembly and add that in right now. So I'm going to come back in here to the distance mate. I'm going to unsuppress this. That's why I didn't delete it, because I knew I had to come back to it. But instead, I'm going to go ahead and edit it. I'm going to take the flip dimension off, and we are going to put in 80 millimeters right here. And hit my check mark, close out my mate, rebuild, and save. Control Tab back into my assembly and say yes. Okay, so there is the new look. All right, now it wants us to go in here and it goes to this base. So I'm going to right click on the base. And what I'm going to do is come down these double arrows and open them up. Right here in the middle, you're going to see replace components. So I'm going to left click. So replace these components. I'm going to replace base part. Okay, right here, base part assembly. I'm going to say browse, and I'm going to replace it with base part B. Open. Okay, and match name. Okay, rematch mates, and check. Okay, so it's going to give you a whole bunch of errors. It's telling you these are all screwed up over here, okay? So in this case, what we're going to do is we're going to go ahead and make the fixes. Show all mates. I got to move this. Sorry, I got to move this. So here, what I'm going to do is expand this out. We are going to make that concentric. We are going to go ahead and pick that hole right there. Okay, that fixes that one. The face, we're going to click on this. It's going to be this face right here. So you see it starting to jump around. It's okay. This one here is telling me the face, well, we don't need that parallel anymore. So I'm just going to ignore that one. Okay, actually, if anything, I can delete it off of there. And then the angle arm is no longer going to be parallel here. Okay, the angle arm, this is this one. I'm just going to go ahead and delete that one also. Okay, so now this is all clean. Everything's been fixed. Okay, you're going to see no errors. I think it looks like the coordinate system is messed up. Okay, we're going to have to re-add that. Actually, what I'm going to do is edit this. Okay, by going back in and editing this. Okay, going back into here, let me just blow this up real quick, and spacebar isometric. Now, here's the downside to this, okay? Based upon the way this looks, I'm actually going to go in here real quick and do something. I'm going to turn this box on, and what I found is if I hit this back corner enough times, spacebar, I can get it back to the orientation. This is what I was doing the other day, and it really was getting old. But with this on, I'm going to put that right here in this corner. It should set up exactly the same way, which it did. Okay, and I'm going to hit my check mark. And just like that, I have no more red over here in my design tree. Everything looks good. Okay, so now I have my coordinate system back on. I have my 80 millimeters. I have my new base. Now what it wants us to do is in this orientation, it wants us to rotate this. Okay, and it wants us to add in a, let me see, make the necessary changes. It wants to add a 15-degree angle from this. So I'm going to do is go spacebar, top view, and we are going to add a 15-degree mate. So I'm going to go to Assembly, Mate, okay, and we are going to mate that. So if you're looking at the very last page of your PDF file, we are going to mate from this surface right here, okay, to that face right there. We are going to add an angle of 15 degrees. Okay, if I go back to my check mark, this is basically what we're looking at right here. Okay, this is what they have. If you look at it from the top view, this is what you get. Okay, that's the angle. That's what you see on the very last page of your PDF file right here. That's what I'm looking at. Okay, it wants to know the center of mass in this new orientation. So again, you go to Evaluate, Mass Properties, make sure you have coordinate system 1 as your chosen one, and then enter those 3 numbers into the assessment in Schoology. And with that done, okay, you have completed this in 47 minutes and 20 seconds. All right, so at this point, what I'm going to do is do a quick save. So I want to save this so I don't lose this. So I'm going to do a save. Okay, save all. I'm going to put this into my folder. I'm going to call this basically Final Assembly Exam 2. I'll make up a name, doesn't matter, and hit save. Okay, and just like that, you are finished. All right, make sure you go in and enter all this information into the assessment. Oops, sorry, wrong one. Let's go to here. Into the assessment, which is back here. Okay, that will be for assessment number 2. All of your answers will be put into this one. As soon as you have that in, make sure you submit. If you have any questions, do not hesitate to email. Otherwise, good luck. Take care.